Okay, so I'm back. Sorry, I had to take a little pause there because my phone was ringing. So, back to what I was saying is that, if I had to graph the derivative function here, I know it's got to go through those two zeros. The critical numbers are the numbers on the graph of f. The point 0, -1, and 5, 4 are critical points. The critical numbers are this, so wait a minute, maybe I said that wrong. Let me say it again. The critical points are the points on the graph of f that have bumps on them, a max or a min. So the point 0, -1 is a critical point, and the point 5, 4 is a critical point. The critical numbers are these zeros that are going to be the graph on my derivative. Since my derivative is decreasing here, I know this is going to be below. Since the function's increasing here, I know my derivative has to be above, headed back toward that other zero. And then since my function starts to decrease here, I know my derivative is going to take on a negative value, right? That little green negative slope, so it has to go below. So my derivative graph looks something like this. Again, it's just a sketch. It doesn't have to be perfect. Okay? The critical numbers are at x equals to 0 and x equals to 5. The critical points are the points 0, -1, and 5, 4 on the graph of the function. Okay, so just make sure you get that straight. Also, the steepest tangent line to this curve, this original function here, is going to be somewhere right around here, where that concavity changes. So I would expect, since it's going to be steep positive slope, I expect there to be a local maximum at that point. Okay? So that steep positive slope is going to relate to a local maximum on the graph of f prime, and a steep negative slope. So if I had something, like this, call this f, the steepest part of my tangent slope, right? I have a positive here, 0, negative, more negative, a little less negative, back to 0, and then positive. This steepest slope would revert to a relative or local minimum. Right? Again, I have a bump here, that would be the 0 on my derivative graph. I have a bump here, that would be a critical number on the graph of my derivative, a 0. My function is increasing from here to here, I expect my derivative to be above. My function's decreasing over this interval, so I expect my derivative to be below. And then my function begins to increase here, so I expect my derivative graph to be above. And guess what? The steepest negative tangent line there, or slope of the tangent line, is forcing my local or relative minimum on the graph of f prime. And that's all 2.5 is about. Now, I do want to show you on the calculator. Let's see, I think I have enough of a charge I can take it off the... So let's see here. Let's put in the function. So one of the functions in the homework section, but it was even, so I didn't assign it, was 2x minus 3x to the 2/3 power. So this is problem number 4 on page 116. So I put the function in, and I want to see, I want to relate the graph of the derivative to that. So it's math 8, x, var's right arrow, 1, 1, and then over to x again. And now I don't want the derivative at a point anymore, I want it over the whole domain. So I'm going to press enter, and I'm going to wait for those two graphs to come up. So here comes the graph, crazy little graph of f. And then the graph of f prime is graphing, and while it's graphing, look, f is increasing here, I expect f prime to be above the x-axis. Now there's a cusp here, right? That means the derivative is not going to exist at that corner, or that cusp, same thing. And then my function begins to decrease a little bit here, so I expect from 0 to about 1.5-ish maybe. My derivative is going to be below the x-axis, and then the blue graph starts to increase again, and so then my derivative goes back above. Now my sketch may look nothing like this, but I definitely have a problem at x equals to 0 because of that corner or cusp. Alright? But it's nice nonetheless to see that according to that little chart I gave you guys, my derivative is doing exactly what I expect it to, even if I can't sketch it this perfectly. Okay? We're going to have an issue at the cusp. So, this is like a vertical asymptote here, the line x equals to 0, or the y-axis, because the derivative can't exist there. We've got an issue with the function. Capiche? And that's it. So let's just look at problem number 12 from the book real quick. Hang on, baby. My dog wants to go for her walk, so I'm going to take her for a walk after this problem, and then I'll go on to 2.6, I think. So here's the graph of G. A. Where does G have critical numbers? Well, it's going to have critical numbers at x equals -2, at x equals 0, and at x equals to 2, right? Because those are the bumps on this graph that are going to relate to the critical numbers, or the zeros on the graph of the derivative. On what intervals is the derivative negative? Well, look, my function is decreasing from -4 to -2, so I know my derivative has to be, graph has to be below the x-axis. Then it increases from -2 to 0, so I know my function has to be above, and it's going to head toward that next 0. Then my function is going to decrease, so I expect my derivative to go back below, heading back toward this next 0, and then my function goes back to increase. So this right here is the graph of my derivative in pencil here. So now I can answer some questions. If I want to graph it, I can. I wouldn't really waste my time. I would focus on the graph of what's given, and you'll get that as you get better at this. But you know, what intervals is G prime negative? Well, it's negative wherever the graph of G is decreasing. So from -4 to -2 and 0 to 2. Okay? Where is it positive? G prime is going to be positively valued, positive slope, whenever the graph of G is increasing. So from -2 to 0 and from 2 to 4. Make sense? On what intervals is G prime, oh sorry, I was doing C. On what intervals is G prime negative or positive? Back to B. Again, G prime is going to be negative where my graph of G is decreasing. So it decreases here, so it's going to be negative there. It decreases here, so it's going to be negative there on that interval. Okay, sketch the graph of G prime, or F prime, I called it F. Let's make it right. G prime. Done. I sketched it. Is it perfect? No, because I don't even know what the function is. But it's good enough. If I had the function, I could be a little more meticulous, but I don't. So this is the best we can do. Alright? By the way, if I get rid of, well, if I look right here at -1, looks like the slope of the tangent line is the most positive, and what's that referring to? A local minimum on the, sorry, I keep doing that, I'm tired. A local maximum on the graph of G prime. Over here I've got the steepest negative tangent line slope, so that refers to a local or relative minimum on the graph of G prime. So I hope that helps. And that concludes 2.5, and again, if you have any other questions, do not hesitate to ask me, because your success is important to me. Okay? So I'm going to stop this here for right now, and when I get home from the walking of the dog, I'll go into 2.6. Okay, and that's going to bring us to section 2.5, and section 2.5 is about relative max and min points. Mainly, Best talks about critical numbers, and that's really the point of this. So let's just remember that a critical number is the zeros on the graph of the derivative if you were going to graph it given the graph of some function. Okay? So I drew some function here. because my drawing is so incredible. And the critical points are points on this graph of f that I drew, such that when I draw a tangent line to those points, it's 0. The slope of the tangent line is 0. So those are going to project onto the graph of f prime as the zeros of the graph of f prime. Make sense? On this graph, so let's just say this is the point 0, -1 or something. This point right here. And let's just say that this point right here on the graph of f is the point, I don't know, 5, 4 something. So again, I'm making stuff up. I can tell that if I draw a tangent line here and here, it's going to have a slope of 0. Okay? So it means the derivative equals to 0, or the slope of the tangent line equals 0, or the instantaneous rate of change or instantaneous velocity or velocity, they all mean the same, is 0 at the point where x equals 0 and x equals 5, right? And then, you know, I see that this function f is decreasing from here to here, so I expect my derivative to be below the x-axis. I see that my function's increasing from here to here, from 0 to 5. So I expect my derivative to be above, heading toward that other 0, right? And then my function decreases a little bit, so I expect my derivative graph to be below. Why? Well, once again, the slope of a tangent line, the derivative here is negatively valued. Here it's positive, here it's positive, positive, positive. It's going to 0, here it's negative, right? So I expect it to be below the x-axis, above the x-axis, and below.